My name is Yevgeniy. I'm one of the co-founders and the CEO of Shakudo. I was previously at BMO, where we built the BMO AI lab. I started it, and previously at Borealis AI, did a bunch of random things before that. So worked in venture capital, worked at Amazon, and actually started my career as a theoretical computer scientist, which sounds very, very different from what we do today, and it is. So excited to be here, and I'll introduce Shakudo. So Shakudo is our company. It's a new brand that we launched actually today. There was a beta kit article. We're entirely focused on creating the best platform for data scientists, both in terms of user experience and in terms of the level of independence that it provides for scientists when it comes to the needed engineering support. And so the data science teams that use our platform are usually require very little support or none at all, which obviously allows them to move faster, but also significantly reduces the engineering costs for their businesses. So I won't talk about our product today, but the space that we're going to talk about is certainly very, very near and dear to us. So let me just start by saying something pretty obvious that will not be new to the folks here, and that AI is in general hard at this point. And so why is it hard? It's because it's this very interesting part of the industry that has become ingrained and ubiquitous across the board. Every company has, not even if they don't call it AI, they'll call it data science or machine learning or something along those lines, sometimes advanced analytics, but every company knows that it needs to read data, analyze it, and let machines make certain decisions based on that data. What almost no one has is a process or a pathway to kind of make it work for their business. Right? So generally speaking, the way AI and data science has played out in the industry is everyone realized that it's important. Everyone read the Gartner reports and the quadrants and the hype cycle charts and put a certain amount of dollars toward data science or AI within their businesses, and with the expectation that if you put X dollars in, you'll get X dollars of output out, which is I think all of us know is not the case, right? So why isn't it the case? So let's kind of unpack this a bit more. So first of all, it's actually really hard to identify a problem that is a good use case for AI. And there's many reasons for that, but the one big reason is that the industry thinks of products as something that either works or doesn't work. And in many cases, AI-driven products work, probabilistically. They work sometimes. They work with a certain degree of accuracy, which requires you to design the products differently, right? And so some companies are really good at it. Most companies are not. The second reason that it's really hard to do AI in practice is because the problems are still ill-defined, because pretty much every organization has its own custom use cases or use cases that are specific to them that are yet to be defined. You need to find the deepest level of expertise in terms of talent to make progress. And so it's not yet at the point where you can hire the experts, or like, let's say in the space of big data, you can hire people who are just expert users of the big data platforms and frameworks. That doesn't exist for AI as much today. So if you truly want to leverage AI within your organization, you actually do need to hire people who understand it all the way down to the details of the math and how the algorithms work, and which algorithms work and which ones don't, and why. Retention is hard. I don't need to talk about it. I think retention is now, this particular bullet point is not new. I had it on this slide in different variations for probably the last couple of years, but this period of time is where talent is just such a different beast, right? So post-COVID, if you can call where we are right now post-COVID. I mean, COVID is not over, but people are hiring like it's over, and so talent is just craziness, and retention is really hard, especially for talent that is highly in demand and highly specialized and still scarce because of the level of expertise that's required. And so finally, so how do we scale? So if AI is so hard, if every problem requires custom definition, kind of going all the way to the basics, and you need to have your army of PhDs that have actually published papers in the space to make progress, then how do you truly scale as a business if you want to leverage AI? So one approach is you call other things AI, right? So you kind of just define a product that feels more intelligent, and you don't have any actual machine learning or AI in the scientific sense of it in your product. And that, from a business perspective, it could be a viable approach. That's not what we're going to talk about. What I'd like to talk about is how do you approach AI at scale if you truly want to use machine learning or AI. Right, Adam, I'll assume that I saw in the agenda the questions come at the end, but if anyone wants to ask questions, I'm perfectly happy to answer as we go.
Yeah, that's right. Well, if anybody has questions, please put them in the Ask a Question tab. And just for the sake of keeping you, keeping you on your flow, we'll answer them at the end.
Cool. And I'll try to go faster because I realized I'm already like 10 or 15 minutes in.
All good. All good, Yevgeniy, mate. Take your time. Take your time.
All right, sounds good. So very briefly about Shakudo. So as I mentioned, we're an end-to-end platform. We're focused on simplifying and automating the engineering and the DevOps activities around data science and machine learning. As surprising as it may be, even though all the founders come from a kind of machine learning background, we actually don't do the machine learning work itself. We instead understand how others do it, or we try to, and we build the best user experience for them. So that is our business model. We tie together the tools that scientists love to use the most. We don't try to lock you in. We build a platform that's kind of designed to survive time, because it will continue to evolve with the industry and continue to operate and interoperate with the best tools that exist out there, rather than proposing yet another proprietary way of doing things. And finally, the platform is designed for all ranges of machine learning. So from very basic analytics and report generation to highly sophisticated computer vision models that need to be trained on large clusters of GPU nodes. So that will be the extent of my pitch today. All right, so let's talk a bit about what happens with AI in a large company. So in a large company, and I used to have on this slide, an image of two groups of kids pulling a rope and like doing kind of a tug of war, but our product manager removed it, and so now I have to explain what it is. She's great, by the way. But anyway, so why is AI hard? So AI is hard because it's so ill-defined, and because in large organizations, the decision-making tends to be federated, and there's no kind of centralized decision authority or architecture authority that can tell you, what, this is how we're going to approach all AI problems in the company. Sometimes it goes a little bit in that direction from an infrastructure perspective or a governance perspective, but in terms of how to pick use cases, how to solve them, how does the company leverage AI when it's a Fortune 500 company? Other than the big kind of the FANG, so the big tech companies, I don't think anyone actually does it well. And so you end up with many of these different islands across the organization, where each island does AI in its own way and sometimes calls things AI even if they're not. So let's unpack the process of a typical AI project within an enterprise today. And I'm sure there's many different variations on this. So this is just a variation or a generalization of the variation that I'm most familiar with, right? So this is kind of what I've seen. I'm sure there's many different ways to define this. So the typical flow is when, a problem is defined. So let's put kind of the problem definition stage aside, and let's just assume there's a way to do it, even though that could be an entire presentation or in a discussion topic on its own. But really what I want to focus on today is how do you make it happen once you've settled on a problem. And so once the initial problem is defined, there's typically kind of a 3 layers type of process, where in the first layer, it's all about getting the data and transforming it, making it ready for consumption by the data scientists. In the second layer of this process, that's when the actual data science and machine learning work starts. And this is where the extent of complexity and sophistication varies wildly, right? It could be that the data was transformed and you've calculated some basic statistics like averages or max and min or something like that, and that is the extent of the data science that you do. It could also be that there's a very advanced process that happens where sophisticated models are trained, data is transformed in non-trivial ways to generate features that may not have meaning for kind of a human that just looks at the data, but has very deep meaning from a statistical perspective. And so that part is very diverse, and there's different roles to play in this kind of middle column. And then the last column is really more on the AI side of things. So rather than analytics or basic data science, it's really when the organization knows what it's doing, is truly leveraging AI in sophisticated and complex ways, and wants to approach it just like any other engineering process, where you do your diligence and you do your work to get the best possible solution, and not just stop at the basics. So that's the flow, and there's many permutations of it. And what I wanted to talk about is the roles and the different players in this flow. So the 4 that we're going to talk about are, the researchers, the ML engineers, the data scientists, and the data engineers. And I'll try my best to define those. Just like the process before, these roles as well have many different meanings across the industry. But I think there's general concepts we can agree on. So the data engineers are, by and large, the group of people who will consume who will find the data, know the data best, consume it, and transform it as needed, and make sure it exists where it needs to exist and can be processed at scale as needed. The data scientists will typically do some amount of data engineering, sometimes all of it. They'll then take the data, again, process it, potentially generating additional features or statistical insights, and then either train models on it or not. The AI researchers exist in the same world, but they typically don't actually want to understand the data from a business perspective as much. What they want to understand is the data from a statistical perspective, or from a kind of purely, what will the algorithm do with it type of perspective. And they'll develop new model architectures and kind of train new types of models potentially. But and of course that sometimes spills over into data science. But by and large, they're the ones that focus on the algorithm side of things rather than the data itself. And the ML engineers is this rare breed of engineers, which is increasingly in demand, increasingly expensive in the industry, for the following very simple reason. To tie all of this together, as we'll see shortly, you need to both understand the machine learning to the level of extent that your data scientists and AI researchers understand it. And you also need to be able to build production software with all the bells and whistles that it comes with. So monitoring and alerting, testing, knowing how to manage memory, all of the fun things that we all love about production systems. So let's kind of try to talk a bit more about the flow, right? So typically the data engineers will find the data and transform it. The data scientists and the researchers will then take over and produce models. The ML engineers will take the models and wrap them into production type of packages and deploy them. And that's the product. Obviously grossly oversimplified, but at a high level, that's what I've personally observed happen pretty much everywhere. Let's make it a bit more interesting. So where does each of these roles sit? So the data engineers clearly sit in the first layer of the process, where they can bring in the data, produce an output data set for further processing by data scientists, and then they either stay involved or not. But definitely the data scientists will be the ones that kind of take the very first output from the data engineers and produce, new features. They'll build in their expert knowledge into the data set by generating additional features or by requesting different types of transformations. And then the AI researchers may participate in the baseline creation, and they may participate in kind of training different state-of-the-art models. But generally, what they want to be doing is creating new model architectures, right? And then the last kind of layer is where the AI researchers really thrive, and sometimes it's partially covered by the data scientists, but it's really the more sophisticated fine-tuning of the solutions where the AI researchers sit. So let's talk a bit about AutoML. So what is AutoML? I think by now everyone knows at a high level what it is, right? These are various packages and products that allow you to create a model based on an input data set without knowing which model will work best. So essentially try many different combinations based on a variety of different selection algorithms and just produce a fine-tuned model which does well on the problem that you care about. There's both open source frameworks for that. One that we like in particular is AutoGluon and AutoKeras, and there's also commercial frameworks. The big difference to me between the open source and the commercial frameworks is, and it's a bit different for AutoML than for other machine learning products, is that commercial AutoML makes it too easy and too it's very kind of appealing that you can just throw in a data set of any size into a Google Cloud or an AWS AutoML product and get a working model. What you don't get is any insight into how it works and any ability to kind of extract it out of the platform, which is of course the business model there, right? You create a dependency on this closed product, and then you have to build the rest of your system within that environment. And that may make sense, but to us as scientists, it kind of scares us, right? If you're building a solution and you just throw data into a black box, you get good results out without knowing why. It is a little bit scary. And so we generally prefer the open source frameworks, but there's some very good commercial ones out there as well. The benefits are that you're starting to create a consistency and the level of repeatability of a machine learning project process that is starting to feel a lot like engineering. Right? So with software engineering, there's decades of fine-tuning of processes that allows good engineering teams to operate like a machine. They get the requirements fed in, and then the requirements get translated into working code within certain predictable or largely predictable timelines. Obviously, it doesn't work perfectly like this all the time, but the better the engineering team, the better they are at perfecting that machinery. Whereas with data science and AI, that really doesn't exist systematically in the industry. What AutoML allows you to do is move in that direction, where kind of the model generation piece, it can be abstracted away and done within certain constraints, right? Can be done in a predictable, repeatable way. And so let's go back to that chart that we were looking at before and introduce AutoML into it. So what are some of the areas that where AutoML can play a role? So it's all these, it's like that robotic arm that you see that's surrounded by a red square. So that's where AutoML can be helpful, right? So baseline creation, I would say, is the #1 most common use case for AutoML. because you know, even if you're not ready to give up your model building time and capabilities, it still makes a ton of sense to kind of take an AutoML framework, apply it to your data, and see what's the best baseline you can create in 5 minutes. Right? There's the cost of doing that is very low, and the benefit is potentially saving yourself, you know, months or weeks of work. So baseline creation is for sure a good fit for AutoML. Of course, you know, trying out many different state-of-the-art models is another one. So if the AutoML framework is up to date, it will have a constantly, you know, updated kind of selection of models that you can try, and it can try them all automatically on your behalf. And then, you know, then there's the more sophisticated parts, which you may or may not need in your project, right? Like loss function selection, or, you know, architecture search, and so on. The other thing I wanted to convey here is, alongside with that robotic arm, we've added other roles that can now start performing these different steps in the machine learning and data science workflow. So, you know, the baseline creation, which was previously performed by either data engineers or data scientists or researchers, can now start, you know, to be done by the ML engineers, which can just automate it. Same, you know, experimentation with state-of-the-art models no longer requires you to know what state-of-the-art is necessarily. You just need to kind of have a high-level understanding and know how to operate AutoML. And so that makes this activity a better fit for engineers and data engineers. And so the point here is that AutoML starts to democratize the access to kind of going through the flow end to end, even if you don't have a highly sophisticated research team or highly sophisticated data science team. Now, I mentioned earlier that ML engineers are this rare beast that is increasingly expensive. And so that is still the case. And I think where kind of tools like AutoML or like, you know, our platform are helpful is in taking regular engineers who are just excellent software developers that are full stack, and making machine learning accessible to them in a way that allows them to go from beginning to end, right? So it's not helpful if you just solve one step of this process, but you still need to kind of bring in the heavy artillery or the heavy experts to kind of get to the end of it. It only helps if there's a path to go from beginning to end with the skill sets that you have on the team. And so AutoML helps with that. You know, platforms like Shakudo's Hyperplane help with that as well. All right, I know I'm way over time, so let me just skip ahead a little bit. So one thing I want to emphasize is, with kind of MLOps and, you know, tools like AutoML becoming more and more common, more and more clear requirements of any data science team, what's becoming kind of much more pronounced is the value of the domain expertise that many data scientists built over time. Right? So there's a tendency of scientists to learn what their data is, you know, what it represents, what are the different peculiarities that exist in it, but that is not very explicit in the value that, you know, when a company thinks about the value of their data science team, the value of understanding the data as kind of a human is not talked about explicitly much. Sometimes it is, sometimes it isn't. But when a lot of the more common model generation activities are automated, that kind of domain expertise and understanding of the data becomes one of the main value propositions, where the data scientists can operate, you know, an AutoML framework because they understand the data well, and because they know whether the results are kind of make sense, are truly optimal or not.
Are most of your clients already on some cloud platform, GCP, AWS, or Azure, or do you initiate the digital transformation journey when required?
Yeah, great question. So I would say the majority of them already are on some cloud provider or another, but we are working with companies that are both starting the transformation, are in the process of transformation, and some that have decided to go with an on-prem infrastructure that they manage themselves entirely. And just said no to cloud. So we have the kind of the breadth of different setups.
As we know, to perform good ML or DL learning models, we need large amounts of data. When it comes to solving real life problems, most companies refuse to give out information about them for fear that their business will be stolen from them.
Yeah.
So, what should we do to get exact results without having all the data?
So, so there's a couple of ways to answer this. I can tell you what we do, and then I can tell you what some others in the industry do. So, what we do is we've built our platform to be deployable anywhere. We usually deploy it within the customer's infrastructure, whether it's their cloud environment or on-prem. The Shakudo platform deploys within the customer's environment, which allows their data to never leave their premises, right? And that's not just because of fear of their business being stolen from them, but in many cases, if it's a B2B company, our customers have agreements with their customers that they're not allowed to move any data out of their infrastructure. So even if they trusted us completely, they're just contractually not allowed to let the data leave. And so we have to deploy within their environment. One other approach, which I'm quite excited about, and there's some interesting companies emerging in the space, is letting data leave, but not the data itself, a privacy transformed version of that data. Right? So there's this concept of differential privacy, which injects random noise into data sets and preserves kind of certain statistical properties, but actually changes the data itself. And so that allows you to move data around, or to not, kind of break any contractual obligations, to not leak any private information, but still maintain the rough shape of the data to work with it. And then there's many different variations of that concept. And of course, like the third option is just like the brute force, no, we will just go through all the legal battles to get to the point where you can move the data out and use it. And I think many companies are not fighting that battle, but it is a possibility.
Have you seen some data analysis exercises lead to ML projects?
Yeah, absolutely. I think if anything, that's the more common way in which ML projects are born. It's typically people have a rough idea of what AI or ML can do for them. They predict that AI can classify or make time-based predictions, or kind of segment data and so on. And then these concepts are intuitive. Translating these concepts into actual projects is super unintuitive. So what I've seen happen many times is someone who's ambitious, who's kind of trying to move the business forward, will come up with a great idea that leverages high-level machine learning concepts that you don't need any technical expertise to be able to think about. And then they also have the data set. What they don't have is everything in between, but that's where kind of the data scientists know how to fill the gaps. And so when I was at BMO, let's say, that's actually how a lot of our projects worked, where business leaders came up with a certain idea, and then we kind of helped make the entire process in between feasible and execute on it. It's Shakudo.
Shakudo. And what does that mean? Is that, it sounds like Japanese for something.
Yeah. So the reason we picked Shakudo is, I'll tell you very quickly the story behind it. Our company was called DevSentient. I won't get into it. It was a good name, but we thought about what are we actually like? What is the company? Like, what do we do? And we tied together machine learning tools into a single framework, a single user experience. So if you think about it, it's kind of like an alloy, right? If you think of metals being tied together to form something stronger, more valuable, that's an alloy. And so we are like an alloy of machine learning tools. Well, Shakudo is a Japanese alloy. And then why that one and not some other alloy? It's because it sounds cool.
Yes,
and because the colors are nice, and because the domain was available. So that's kind of why.
Awesome.
But yeah. All right.
Yeah, so much in the name, and I think Shakudo, it sounds awesome. I think it's a nice.
Yeah.
DevSentient was good. Shakudo is way cool. I love the logo, the rebrand, mate. You've done really well. So I wish you the best of success again. Yevgeniy, thanks so much for stepping up tonight, mate. Best of luck with it all. We'll see you around.